we ready to start? Okay, I guess so. First of all, I'd like to welcome everybody in the audience, apart from one person, to the talk. My name is Matt McLoughlin. I'm here to talk about something called CQRS and event sourcing. I just want to make a couple of points up front. For those of you who've seen these two terms, you've probably also seen them in conjunction with another term, which is DDD, or Domain-Driven Design. Not really going to be covering that much in this talk. Just going to really focus on CQRS and event sourcing. Another point to make is that I bought a Surface book about 2 weeks ago now. I don't know if you guys have seen them with the pens and everything. So I thought, hey, it'll be a great idea. I'll hand draw all my slides. It'll be a lot quicker. It's really not. This thing took forever to draw. I must have written this single slide maybe 20 times before I got it right. It also turns out I've got horrendous handwriting. Also turns out I've got horrendous spelling. And no spell checker. So if there's any spelling mistakes, I think there may be a couple. I apologize in advance. But yeah, so this is my talk. I wanted to talk about CQRS and event sourcing. Why this talk? Well, I've been working in fully or partially event-driven, event-sourced systems for a few years now. And over that time, I've started to see it become more popular and more people become interested in it, which I think is pretty apparent by the number of people who've turned up to this room, which is kind of daunting, but there we go. And I wanted to give a talk that kind of goes over the basic principles of these two ideas and talks about kind of like the base-level architecture that you can build using these two design patterns so you can go away and start building this stuff yourself. And also, since I've kind of got into this, when I've seen new people come along, the most commonly asked question is, what framework can I use? What framework is there out there to build these kind of applications? And there isn't really one out there, and if there is, it's not particularly good. And quite frankly, you don't need it. The principles are pretty simple, and once you actually start to write this stuff yourself, you'll realize it doesn't take up that much of your code base. I mean, I've implemented a basic example in a few hundred lines of code at most. So looking for an architecture, probably not worth it. Better to write it yourself, then you understand it better. So, what are we going to cover? Well, firstly, I wanted to talk a little bit about event sourcing and the theories and the ideas behind that and why it's good, why it's a good thing to do and where its advantages lie. Then I'm going to talk about CQRS and how that works and the advantages that brings. Then I'm going to talk a little bit about how the two interact together. We'll then go on to look at a typical architecture that you'll see time and time again. And then hopefully, successfully, I'll demo some code which will kind of give you a little bit of an idea of how you can go ahead and build these things. And hopefully that'll work. We'll see. Most of the code is going to be written in C#. It translates well to most other languages, so I'm sure that'll be fine. Now, currently I work in the north of England, which you can probably tell by my accent, around about Leeds, Yorkshire. And I work for the Leeds NHS Trust, the Leeds Trust. And we have this idea of something called an encounter or an episode, which basically it deals with a patient's journey through the hospital. So it deals with when they get admitted and how they get admitted, which wards they get transferred to, which doctors they see potentially, and also, and hopefully, when they get discharged. All right? So that's kind of the domain, the small section of the domain that I'm going to be using as an example throughout this talk. So just to explain that up front. So, event sourcing, who's heard of it? Okay, fair enough. That's quite a lot of people. That's good. The basic idea behind the event sourcing is a pretty basic idea at its heart. And if you've ever seen any of Greg Young's talks, you'll know he's been around for quite a long time in other industries. It's only been recently that we've really started applying it within our own. And at its very basic nature, it's just a different way of storing the information within your system. In a traditional application, you normally end up with something like this. You may end up with an encounter object, which is, like I say, what we're going to be talking about. And upon that object, you'll have a number of methods. You'll have one to admit the patient, one to transfer the patient, and one to discharge the patient. You may have more. You will have more. And each time you attempt to execute one of these commands, if it passes a business validation, it will result in you storing some state in the database or some document store, right? So if we look at this example, we can see in the first instance we admit the patient. We've admitted a gentleman called Tony Ferguson to Ward 10. and the admitted flag is set to true. When we transfer them, we then update the ward. We move to ward 76. When we transfer them again to ward 34, and finally, when it comes to discharging them, they're no longer in a ward, so we set that to null. And say is admitted is false. Event sourcing works in a slightly different way, but rather than continually updating the state, what you actually do is you store the events that are the result of that command being executed. So again, looking on the right-hand side, you can see when the patient's been admitted. When you admit the patient, you can see the patient admitted event. When you transfer the patient, you can see the 2 corresponding patient transferred events. And finally, at the end, you can see the patient has been discharged. A couple of things to note here. It's common practice to refer to the events in past tense, because once the event has been generated, then it's already happened, so it's just a good naming convention. Also, it's often a practice to just store the information relating to that event with the event, as opposed to storing the entire object every single time. So that's the idea behind it. Incidentally, with the original way of building this, you often don't actually end up with admit patient and transfer patient and discharge patient. You normally end up with a method called update patient, which tries to do everything. I don't know why it is that in this industry we seem to have limited ourselves to just using get, create, update, and read as number of events. So for each of the encounters, we store a number of events, all relating to the history of that encounter. And if we do this, we use this technique for all the objects within our system, we end up with a stream of events that go back to the point in which the system was created. So you end up with something looking a little bit like this. Now, this isn't relating to our domain, but this is a piece of software called Event Store, which is a persistence mechanism purposefully built to store events. And you can see here it's obviously relating to some fraud checking software, and you've got a number of events that have happened over time to a number of different objects. Right? So you end up with a stream of events. But why do you want to do this? Why do you want to go to the effort of storing the events rather than state? Because it does take a little bit longer. It takes more time. And there's a number of domain-driven design reasons why you'd want to do this. It's useful to think about your system as a series of events in certain situations. But it also brings with it a couple of technical reasons why it's good. And the first one, one of the primary reasons, is around auditing. So if you think back to this example we had, which is patient admitted, transferred twice, and then being discharged, if we only ever store the state, we'll lose the record. We'll lose the fact that they've been there on ward 10. Whereas if we store all the events that have happened, then we'll have that information forever in this stream of events that we've got within our system. There are other ways to do it. Who's done this as a method of auditing tables? I'm pretty certain not everybody who's done it is putting their hand up right now, because I know I've done this, and I've done it using database triggers, which is potentially the most evil thing ever. So the idea with this is that each time a patient is updated, you take a record of you record the original record and then insert or update the new one. Often in some other patient audit table or the like. Now this, although can work, has a number of problems. Firstly, you're storing a lot of information here that's not necessarily important. So say, for example, when you change the ward, you don't really want to be duplicating a record. So although space isn't often a premium, it makes sense just to kind of remove that information. Also, to actually work out what has changed, you'll end up comparing each row to the one below it to see which values have changed. And that can be quite a tricky process. And also, because this happens after the fact, because this happens after the patient has actually been inserted, you can never really be sure that it's right. It might be that the trigger's failed, somebody's removed the trigger. It's not reliable. And finally, and probably most importantly, is that although this will tell you what information has changed, it doesn't tell you why it's changed. You know, it could be numerous reasons why they've moved wards. If you store with events, you store why it happened and what happened. What happened and what changed. And when it comes to getting audited, that's quite a powerful thing, because the first thing you get asked is, well, why has that changed? And if you just store an audit like this, and you've got no real way of knowing, other than maybe going back to some transaction logs or interrogating some web API logs or something like that. So that's fine. We've got the idea. We still have a stream of events as opposed to just updating the state. But how does that actually work in the code? So in order to be able to make a business decision, to be able to validate something on the object, you still need to have it at its current state, right? And in order to do that, you need to, within event source system, you need to replay the events against that object. So in the case that the patient has been admitted, that's pretty simple. It's the start of the encounter, so we just save that single event. When we want to transfer a patient, well, we want to make sure they're admitted first. So in order to check that, we have to replay the patient admitted event, and then we can attempt to transfer the patient. Equally with the second one, you replay the patient admitted, the patient transferred, and then try and transfer them again. And then finally, when it comes to discharging the patient, we replay the first 3 events, and then you can attempt to apply the patient discharged event on the end of it. Now, this does actually bring with it a number of problems, which are pretty apparent, really, is that if every time you want to look at this object, you need to replay all the events, that's going to get quite expensive. Now, for the purpose of just updating the encounter, that's not so bad, because most systems are 20% write, 80% read. And also, you're only working with a single encounter. Now, if your boss comes along and says, which is a typical requirement, I want to see all the patients and which wards they're on, doing it this way would require you to pull out every encounter, replay all the events that have ever existed against those encounters, group them together into wards, and then return them as a view back to the user, to the customer, which is not very efficient. It takes a long time. And that is where CQRS comes into things. Now, CQRS is kind of an extension upon an idea by Bertrand Meyer called CQS, which is command query separation. And that's the whole idea that a method should only ever be responsible for executing a command against an object, or it should be responsible for retrieving information from the object. It should never do both. And it makes a lot of sense, because if you have a method that queries the data and also changes it as it's coming out, well, I mean, that's going to be an absolute nightmare to debug or manage, especially if it's a third-party API. If that's happening behind the scenes, and it has done in the past for me, that can be incredibly confusing to debug. So CQRS, which stands for Command Query Responsibility Separation or Segregation, I can never remember which one it is, takes that a step further, and it says that you should have a separate object for your commands and a separate object for your queries. Okay? And when you think about event sourcing, that makes sense. You've created this object that's great for writing. It's perfect for writing, but it's absolutely horrendous for reading, for querying. So it makes sense to look at creating a new model to view. And you've probably done this before anyway. If any of you have ever used Entity Framework for writing information to the database and then maybe use an SQL view for reading from a database, it's the same sort of idea. But when it comes to event sourcing, it does work really well with CQRS, because you can actually make use of those events to generate your read models. So these are the events that we had earlier in the system. We've got patient admitted, patient transferred, transferred again, and patient discharged, right? There's no reason why within your system you can't build a mechanism that when it sees this event, it can be used to insert a record in a row. So going back to the previous example, we want to see every patient on every ward. When a patient gets admitted, we can add a row to the table or the document store, whatever you choose, saying that Tony Ferguson's been admitted. When it sees a patient transferred event, there's no reason why we can't use that and build a mechanism that will then update the ward. Similarly with the second time, update the ward to 34, and finally, when it comes to discharging the patient, we can actually just delete the record from the table because we've got it in the event stream, right? More often than not, we'd end up doing something like a soft delete, right? Is admitted, false. We don't need to do that, it's in the stream. So it's a very powerful thing, right? To be able to build these views off the events. Now, when your brain starts to go to that area and you start thinking that, all right, I've now got a write model and I've got a read model, the next logical step is to say, well, why can't I just create multiple read models, right? You know, we want to see this data in multiple different formats, multiple different projections in different parts of the system. Why can't I just look at the patient admitted event and use that to generate two views? So on the left, we've got a ward view, which shows the patients on the ward. And on the right, we've got the demographics, maybe shows the ages of the patients that have been through the hospital. Okay? Now, combining these two things is incredibly powerful because building your projections of the data from your events allows you to do a number of different things. Firstly, if for some reason your ward view gets defunct, it becomes corrupt, the information it is wrong, maybe you've introduced a bug. There's nothing stopping you from just deleting all the information within your ward view, fixing the bug, and then just replaying all the events within the system against that ward view and building it again from scratch. All right? So that's incredibly good for fixing bugs. It's incredibly helpful. Also, there's often a situation where somebody will say, okay, that's great, I've got the ward view, but what was it like last week? So in that situation, you could either just create a new view and replay all the events up to and including last week, and then you'll have your ward view as if it was 2 weeks ago, a week ago. And finally, and this one has helped me numerous times in the past, is, so often is the case that you have a system in production and your boss comes along and says, yeah, it's great, I'm happy, but I want to see the demographics. Now, you haven't built this report. It doesn't exist. I want to see the demographics of everybody who's been through. Because, again, because you've got an event stream, there's nothing stopping you at a later point in time building this demographics view, replaying all the events again in your system against it, and it'll be as if it was there since the beginning of time, which is great. And that saved my bacon numerous times. So you can literally go, well, not crazy, but build such specific views of the information. You don't have to be generic about these things at all. If you've got an index page, you can build a projection for the index page. A detail page, it requires more information, so you can have a view for the details page. It really is quite powerful. So that's kind of how CQRS and event sourcing work together, right? So the next step that I want to go on to is talking a little bit about how the architecture actually looks for these things. It looks with these things. My drawing is really horrendous. So there's multiple derivatives of this kind of architecture, but essentially they all end up looking pretty much like this. People customize the ideas for different situations, but essentially you'll have a client, which is some kind of web API or a mobile client. WinForms, if you're unlucky, any WinForm developers? Nobody's putting a hand up. Oh, right, we've got some WinForm developers. I'm sorry, guys. It's unlucky. Yeah, so your client, be an MVC application or whatever, issues commands which go through a bit of a pipeline and interact with your domain. Your domain then produces a number of events that get saved against an event store. Then you have a projection manager. Really don't like using the term manager. I think it's too generic, but whatever. It's gone with it on this one. Which then gets which projections are interested in those events and then produces some view, which then can be read or queried by your client. So to go into it in a little bit more detail, we saw the admit patient command earlier on. Now, although this pattern isn't really part of event sourcing in CQRS, when you start thinking about your system as a series of events, it also makes sense to start thinking about the commands which generate those events. So this is a nice little pattern we can see quite a lot, which is a dispatcher. It's kind of a mediator pattern. And basically, you have an admit patient command which says what I want to do and provides the information, but it needs to do it. The dispatcher will then say, okay, I've got an admit patient command. Which handler do I need to process this command? So in this case, it looks for the admit handler. This admit handler then needs to interact with the encounter, right? So the encounter's got a couple of responsibilities, a few responsibilities. The first thing is it needs to be able to store a list of events that it produces. So if you execute a command against that encounter, it needs to be able to store the event that gets generated as a byproduct of it. It also needs to be able to keep a record of its version, which I'll come back to in a second, and it also needs the ability to apply any events that are already in the system. So if you stored 3 or 4 events already against this counter, it needs the ability, as we showed in the previous slides, to be able to rebuild itself from those events. Now, the reason the version is important is to do with concurrency problems. So imagine a situation where 2 users both access the same encounter at the same time. These encounters have already had 5 events applied against them, so they're both at version 5. The first user executes a command against it, it generates a new event, and then it attempts to save it back to the database, to the event store. And it says, okay, I'm version 5, I expect the next version to be version 6. And he says, yes, next version, I expect it to be version 6, you're okay, you can save. The second encounter, which is currently still in progress, when he then tries to save to the event store, it goes, I expect the next version to be 6, but it's now 7. So it'll throw an exception, and you can bubble that back up to your user and handle it however your business sees fit. It might be that you just get them to retry the command, or give them an error message, or whatever works. Okay? So that's why the version is important. So we've now got a series of events in our repository, in our event store. The next thing we need to do is actually start to generate a view from these events, right? So as we've said, those models aren't great for querying. So not dissimilar to the way the command mediator works is that we have a patient-admitted event comes into the system. Our projection manager will then figure out which projections care about that event, and then it will give them that event. That ward view projection, as it is here, will then process that event and generate or update the ward view. There's another concept that's important to take note of here, which is checkpointing. Now, there is a very good, strong possibility that your application is going to fail. It's going to, it's going to drop. It's going to crash at some point. When you start up your application again, the last thing you want to do is start from the beginning of time and go through all your events again. So the idea here is that every time you process an event, you just mark a checkpoint off somewhere, so that when your application crashes and you start it again, it will start from where it left off. Okay? Now, there is still a bit of a problem with this architecture, and that is the fact that if you start building your application like this, and a user comes to interact with it, and they issue a command to admit the patient, they then have to wait for all the events to replay. It then applies an event on top of it, which then gets saved to the event store. You then have to wait for what we have now, potentially tens of different views to get updated before it can then return that this command has been successful. That can be quite slow. It can make the application quite unresponsive. So there is the option to take this projection management and push it off into a different process, be it a Windows service or a console application or something simple like that, and have that process the events on its own independently. But that does bring a problem with it, which is this word, 2 words. Eventual consistency. I think I've spelled it right. Yeah? Anybody? No? Okay. And the idea is, as it says, that your system will eventually be consistent, but it's not guaranteed to be consistent at any point in time. Because you're processing these events in a separate thread, it does lead you to the possibility that when a user issues a command, you then now return successful when the event has been saved. Because the event's getting processed in a separate thread, they think it's been successful, but when they try and look for that information, it may not be there yet because it still hasn't processed in all the views. This is kind of a scary term to a lot of people. They get worried about this, and especially if you talk to front-end developers, they don't like the idea that when you issue a command, the view's not there instantly, right? Realistically, in most systems, the time it takes to process an event is minimal. I mean, in our system, it's under a second, so the chances of it happening are pretty slim, but it's just something to be aware of, and it can catch people out. And as an industry, we've almost like we've bred people to think that as soon as they issue a command, that it propagates out across the world, and everybody has that result instantly. And when it's like it's something we've enforced upon ourselves. When it doesn't happen, users get a little bit confused. In actual fact, if you go back to paper-based systems, the eventual consistency was days, and that before the form got taken down to an office down a corridor or what have you. So it's just something to bear in mind, and it does catch a lot of people out. Okay, this is the scary part. Got to do a demo, okay? Now, I say this in every single one of my talks because I'm always nervous, but have you ever been in a situation where you're sat in your office and you're happily typing away, you get on with your work, and all of a sudden your colleague will come up and stand on your shoulder? Not actually literally stand on your shoulder, that would be a bit crazy, but stands behind you. And all of a sudden you completely lose the ability to type. Your fingers turn to sausages, right? It's like you've never used a keyboard before in your entire life, okay? Standing up on stage in front of all you guys and doing this is like that times 100. Okay, so I'm going to make a lot of mistakes, but hopefully we'll get through it and I won't make too much of a fool of myself. Okay, so can everybody see that? That's great. Okay, it's a little bit small, but I've increased the font size, so hopefully that's okay. So in the solution, I've got 3 separate projects. I've got a patient management project, which, I apologize again, it's pretty small. It contains the admission and discharge transfer namespace, which contains all of my business logic, and then it's got the framework, which is all the infrastructural code around these architectures. I've then got a separate projection manager. This is a bit, as we mentioned earlier, that is responsible for taking these events that are in the event store and generating a number of views from off the back of it. And then finally at the bottom there is a very, very small looking test console which just attempts to admit a patient, transfer him a couple of times, and then discharge him. So let's start by looking at a command. Now, is that better? Can people see that at the back? Yeah? Nods. Great. So this is the admit patient command that I talked about in the slides. It says what it's going to attempt to do, and it also contains the information required to do it. So I've got the patient ID, the patient name, their age in years, the time of admission, and ward numbers. I'm also using a constructor to create this. It turns out that they're not just for dependency injection. You can actually use them to make sure that your object's in a valid state. It turns out that's pretty useful. Sorry, that's an annoyance of mine. So we've got this admit patient command. We then need to handle this. And if we come into the handlers, you'll see we've got 2 handlers here. We've got one for admitting the patient, and we've got one for discharging the patient. In the first case, admitting the patient is the start of the encounter, so we use the constructor to create that. And when it comes to discharging the patient, we have to get the encounter out of the store. So if we actually look at this method here, we'll see that when retrieving an encounter, the first thing we do is we create an instance of it. We then get all the events that have ever existed for that encounter based upon the type of object that it is and the ID. And then for each of those events that we retrieve, we then try to apply it to the encounter. So that's the whole idea of rebuilding the encounter to the current state so that it can be worked with. Okay? Then when we've done that, we clear all the events and we return the aggregate. The next thing we do is then we try and execute a command against the aggregate, against the encounter. So if we go in here, we can see that we need to discharge a patient. The first thing we need to do is check that they're admitted. If they're not admitted, you can't really discharge them. If that's successful, well, we raise the patient discharge event. The only information we need in there is the ID, because that's the only thing that's relevant. I mean, okay, so it might be a case that in a more advanced system you have the time that they were discharged or the reason they were discharged. But at the moment, we've only got the ID. Okay? So we generate that new event, and when it comes to actually saving the event, again, as explained in the slides, we pull all the events out of this. So I haven't explained this. There's a term aggregate root, which comes from DomainDriven Design. It's not so much relevant here, the actual naming of this, but as it says, it's a root of an aggregate. But anyway, we get the events out of the aggregate root, in this case the encounter, we convert them to a suitable format, and then we save them back to the stream. And you'll notice on the end here, we also pass in the version when we're saving this stream, so we know that nobody's updated it in the time that it's taken us to execute the command. Okay. So this is great. We've got the admit patient, we've got the discharge patient, but we don't have the transfer. So let's create that now. This is where I'm attempting to type. So we want to register a handler to transfer patient. We accept the command. And then close it off. See, I've already made a mistake. Yeah. Very good. See, I told you it's hard. Okay. So when we transfer a patient, the first thing we need to do is we need to get the encounter out of the system. So we get it from a repository. And we get it by the ID of a patient. Then we need to execute a transfer command against it. And we need to give it the ward number, Excel. And then the last thing we need to do, as below, is save the encounter back to the system. Right? Make sense? I need some nods. Okay, good. So let's create the transfer command. Or the transfer method, rather. Any of you guys use ReSharper in Visual Studio? Yeah, literally couldn't use it without. So have any of you guys used Rider yet, by the way? All right, I was going to give this demonstration in Rider, but it just turns out that the current license expires today. And when it expires, it's not like, oh, it won't let you log back in. It literally shuts you straight down there and then. So I just had horror thoughts that, I'd be typing away and all of a sudden, nope, you're done. So unfortunately, I had to switch back to Visual Studio. So we transfer the patient. First thing we need to do is make sure that we're admitted. So check patient is admitted. And then if we're admitted, then we need to raise an event called patient transferred. All right? And we give it the ID of a patient and the ward that they've been transferred to. Actually knew that up. Rename that. Okay? So it's pretty clear. We've got a handler that handles that event when it comes in. We check the patient is admitted. If it's admitted, if they are, then it's pretty simple, raise a new event, which can then be saved back to the event store. We also need to be able to handle the fact that we'll need to rebuild this object using that event now. So we need to create an additional method that handles that. So we can say when the patient is transferred, we want to send the ward equal to the ward number. So what will happen now, in fact I'll put it with the others up here, is that when we rebuild this object, whenever it sees a patient admitted event, it will call into this method. Whenever it sees a patient discharged event, it will call into this method. When it sees a transferred event, it will call into this method. And gradually build the object back up to its current state. You just need to register it at the top as well. Right, and that's pretty much it. There's a little stuff that goes on in the background. So say, for example, these patient discharged and transferred events, when I'm calling this register method, I'm building up a map of the event to the when method that it needs to call. So that's just my way of linking it up so that when I see those events, I know which method to call. In fact, I'll show that. So in here, when the register method is called, all I'm doing is adding an item to a dictionary, which is type of T, which is a command, and then a little delegate method that actually executes that. Okay, so that's kind of how the command side of it works. Let's have a look at the projection side of it. So if we look in the main program, there's a bit of setup around here. Most of it's not important. The bits that are important are creating a new projection manager where I pass in a couple of dependencies, along with all the projections that I actually want my manager to run, right? So here I've got a ward view projection. And if we take a look at that, we can see that we've got a number of handlers there. Again, just like the command handlers, but in this case we're handling events. We've got one that handles the patient being admitted. We've got another one which handles the patient being transferred, and finally when they get discharged. We actually have a look at the code in one of these. So let's take the admitted event. We're basically saying when we see this patient admitted event, we want to connect to, in this case, RavenDB, and insert a new patient into the ward view, and then save the changes at the end. When it comes to the patient transferred, in this situation, we want to load the patient out of the database, out of RavenDB, change the ward number, and then save it back. And then finally, when we get discharged, we load the patient out, and we then delete them. Unfortunately, there's no easy way, I don't think, of deleting a record from RavenDB without loading it first. There we go. Maybe. Somebody may know. And that's kind of how, basically how a projection works. Listens for those events, passes them off to the right place, and off it goes. To actually look at the projection manager, when we start our individual projections, so this method here, you can see the first thing it does is it gets to the last position that it was at, and then it subscribes to all the events from that checkpoint. And when it actually processes the events here, the first thing it does is it checks that that projection can handle that event, puts it in a suitable format, and handles it. And then at the very end, as I mentioned in the slides, it updates the projection to make sure that when we restart the application, it's not an invalid, it starts from a correct place. So, if we set this running, well, firstly, so I've got a little web application here, which has got a couple of pages on it. The ward view, we've talked about that throughout the talk. If we set this running, fingers crossed this bit works. I'm not nervous. Yeah, okay. So I seeded the event store with a number of events, which is now processing through. These are all the patient admission events. If we go back and refresh the ward view, you can see that it started to admit all the patients to ward. So this is replaying all the events through time that we've ever had within our system. It's not currently correct because I've only played through about half of the events, right? As you can see here, we've now hit a patient transferred event, so it drops in and it will attempt to update one of the ward numbers. So remove that and keep going. And eventually, so working on my transfers, I think I added too many in here. Please appreciate my uncomfortable silence. My long, uncomfortable silence. Okay, we're getting towards the end now.
You're running this presentation off the Surface as well?
Off a Surface Book? Yeah. So now that it's gone through all the events, it's now to its current point in time now, and there you go, you see the ward view as it is now, right? So we also talked about the idea that we want to be able to create a projection at a later date, and the power that that brings you, that you can build up views of the data as if it's been there since the beginning of time. We also talked about the demographics, so my boss has now asked me that he wants a chart showing all of the patients that have ever been admitted to our system. So let's go and build one of these. So he wants all the patients that have ever been admitted to our system, but grouped into age ranges of 10 years. So I've got a little bit of a dirty class here, which will allow me to look it up. I'm sure there's a better way of doing it. But what we want to say is, when I see a patient admitted event, the first thing I want to do is find out what age range this person falls into. So I can say range lookup.get, and we'll give it the patient age, which is part of the event. I can then make a connection to my database. With that, attempt to load a range because it may already exist. Using the range lookup name to find it. If I have one, or if I don't have one, then I have to create a new one. So we can say store a new range where the ID is the range lookup name. And the count will be 1. And then if one already exists, then I can just increment the count. And then finally, save the changes, right? Does that make sense what's happening there? I'll just put in a little console log so we can see it actually working. And set this to output the actual count. Okay. So now we've created a new projection. We want to be able to see this as if it's been there since the beginning of time. Because we've got this stream, we can do that. We just need to add it into the actual list of projections that we want it to run. And then if we start this running again, hopefully we'll start seeing it process the events. Okay, cool. So you can see it's running through there, recording the ages of all the patients. If we were to stop this, so it stopped when it had about 30 records in each, and if we were to start it again, starts from where it left off. So this is the whole idea of checkpointing. It means your system can crash and you can bring it up again with no problem. Each individual projection would have its own checkpoint as well, so because they all need to manage their own stream. And finally, if we go back, as if by magic it refreshed for some reason, I don't know. You can see that we've got all of the data there built from a projection as if it's been there since the beginning of time. So that's kind of the idea behind the architecture. Just to show the dispatcher very quickly to explain how that works. If we have a look in this test console application, we can see here's an instance of us actually creating an admit patient. So we're trying to admit Tony Ferguson now toward 10. The whole mediator pattern, the way it works, is that you basically call the dispatcher and pass in that event. Within there, you'll see that I've created effectively or registered a map of all of the commands to the code that handles them. All the dispatcher does is actually get the right handler for the command, and pass the command into it. So it's really simple, but it's a really good way of kind of like abstracting away executing and working with the domain from whatever your client is, be it MVC or Web API, right? Now, this is a pretty simple implementation of CQRS and event sourcing. There's certain things, additional things that you're going to want to add to this over time. So it kind of makes sense that when you execute your command, before you do that, you want to validate that your command is successful. Is correct. You may also want to add in some authorization so that only certain people can execute certain commands. So you can kind of put all that in the pipeline of dispatching the command. Equally with a projection manager. But one thing that's important there is that it's to do with ops and monitoring. So you want to be able to see that your event projections are all processing and up to date, but not falling behind, because then it'll make your system seem slower. So you probably want to build some monitoring tools around that. It makes sense to do so. This is all stuff that's not really included, but it's things you maybe want to consider. It's not going to work. Right. So when do you want to do this? As much as the patterns and the ideas are pretty simple, very still are overhead with managing this stuff, especially when it gets into production. And it's only really suitable for certain systems. I mean, if you are actually working on what is effectively data entry, which is, you either create a patient, or you delete a patient, or you update a patient, you're probably not going to get much benefit from this pattern. But if you're actually working on a system that has real process, real interaction between the various users, and a real timeline, then, and real-world events, you look for within a hospital, there's lots of events that take place, and it makes sense to map those to the code. That's when it becomes really powerful. I've seen people build, and so often I've seen people build kind of these systems where you see the commands and you see the events, and they eventually do become create patient, patient created, update patient, patient updated. When you start doing that, if you find yourself doing that, that's when you really want to start looking at domain-driven design, because that'll help you break your system down into a series of events that are useful. Because create patient's not really useful. Update patient, it doesn't really tell you anything that's been going on. So when it kind of satisfies all those things, then it's worth building. And also, you don't have to build an entire application this way. This is the other problem that I've seen happen so often, is that people will have this large-scale application they need to build. And they'll say, right, we're going to event source this, we're going to event source the entire thing. And that's kind of when it fails, because there's certain parts of your application that are just CRUD-based and certain parts which are event-based. So a very good example of what shouldn't be event sourced potentially is user registration. That's always a big one. There's not much benefit to that, but as again, tracking a patient's journey through a hospital, in that situation, it is pretty good. So that's pretty much my talk. The demo that I've given, I've changed a little bit, so I will push it up on GitHub eventually, so you'll be able to have a little bit more of a look of it. There's some links here if you want to take it a bit further and actually investigate this yourself. There's a Google group, the DDD, Event Sourcing and CQRS. Yes, I told you those words are always together. You'll appreciate that I actually typed these links out so you can actually read these ones, because these are the important bits of the talk. So yeah, there's a Google group. There's also the Slack channel, which started up maybe 6 months ago, and that's incredibly active. There's people on there all the time. We've got hundreds of people registered on there now. Finally, at the bottom, there's a couple of links. The first one is a link to Greg Young's Code on the Beach talk, I think it is, which is purely about event sourcing, and it's an excellent talk, and it will give you more of an insight into where it all came from, because Greg Young was kind of a guy who popularized all this, right? And then at the bottom there, he also does a series of online videos. I know he's working to improve them at the moment, and they are paid for, but I've seen them, and I can highly recommend that you take a look at those if you're willing to part with the cash. And finally, again, I'll tweet the link to the GitHub repo at some point later today when I've pushed everything up. So that's pretty much it. So I think rather than keeping you all here longer than you need to be, and if there's people who don't actually want to listen to questions, that's fine to go. But if you want to speak to me afterwards, I'll see the code in a little bit more detail, then by all means come up to me afterwards or after the talk. So thank you very much.